Hello friends, in this session we are going to find out electric potential due to uniform line charge. Okay, so we will consider a very thin rod on which the charges are uniformly distributed. So we will consider a very thin rod. This appears to be not thin, but this is actually thin rod on which the charges are uniformly distributed. I want to find first L is nothing but the length of the rod and this is the center of the rod. I want to find electric field at this point P, which is at the distance y from the center of the uniform line charge, that is a thin rod on which the charges are uniformly distributed. Okay. Now in order to do that, what will I do is, I will first take a small element of this line charge, of this rod. A small element on this rod. This is the very small element on the rod. The length of the small element of the rod is dz, and the charge on this very small element is dq. It is so small that it can be considered to be as a point charge. Okay. And the distance between this element and point P is small r. The distance from the center of the rod to this element is z. Okay? Okay. Now, since this element is so small that it can be considered to be a point charge, electric potential at point P can be given as dV. Why dV? Because this is the potential due to dq charge is equal to 1 upon 4 pi epsilon naught dq upon r. Right? Okay. Lambda is nothing but what? Linear charge density, and linear charge density is given by dq upon dz. Right? So I can write dq is equal to lambda into dz. Okay. So substituting the values, dv is equal to 1 upon 4 pi epsilon naught dq is equal to lambda upon dz. Whereas r, according to Pythagoras theorem, it will be root of z square plus y square. So, root of z square plus y square. Now, if I want to find potential due to the entire rod, I have to integrate. V is equal to integration from minus L by 2. Why? Because this is the center. So, what is the distance? This distance is L by 2, minus L by 2. This is what? Plus L by 2. So, from minus L by 2 to plus L by 2, right? 1 upon 4 pi epsilon naught lambda dz upon root of z square plus y square. Now, all the constants can be taken out of the integration. V is equal to 1 upon 4 pi epsilon naught lambda integration from minus L by 2 to plus L by 2 1 upon root of z square plus y square dz. Right? Now, on integrating this, we get V is equal to lambda upon 4 pi epsilon naught log of z plus root of z square plus y square from minus L by 2 to plus L by 2. Now, after substituting the limits, we get V is equal to lambda upon 4 pi epsilon naught log of L by 2 plus root of L square by 4 plus y square upon minus L by 2 plus root of L square by 4 plus y square. Right? So, this is nothing but the potential at point P due to a uniform line charge of length L. Now, in case if I want to find potential due to an infinite line charge, what would be that? If L tends to infinity. Now, here if L tends to infinity, then V is not defined. It cannot be defined. So, if L tends to infinity, V is not defined. Right? So, this is how you calculate electric potential at a point due to a uniform line charge. I hope you have understood the session. Thanks a lot.